I tell you the power rating on them. So let's just do light bulb 1, light bulb 2. And they're connected in series with each other, meaning there's one singular path for current to flow across. So I will give you the power rating of 1, which is going to be 40 watts. And I'll give you the power rating of 2, which is going to be 60 watts. And I'll tell you that the voltage source is still 120 volts. Please be prepared in the future. Maybe I won't tell you the voltage, but again, you just utilize that chart as a tool and you should be in great shape. Okay, so I want to know everything about this circuit. So you're going to solve for the following. Solve for the following. Total current in the circuit. Voltage drop across each lamp or light bulb, across each light bulb, and the resistance of each light bulb. Now, I said it in the last video, but I realized I didn't write it down. Power is additive in a circuit. So what that means is just P total is equal to P1 plus P2. So just know that, and let's try and solve this. So I'm going to make my standard RIV chart because I think it's really valuable, and I hope that you'll get into these kinds of habits. So RIV, but I'm going to add a section for the power, since that's kind of where I have the most information here. So I have lamp 1, lamp 2, and I of course need a section for total. The lava lamp is trying to do something, please. Alright, this is plugged into the wall, so we have 120 volts, so I'm going to put that in because it's known information. There's other known information. One of them is that power for lamp 1 is 40 watts. Power for lamp 2 is 60 watts. So these are my known pieces of information, and you might have taken a hint from the first thing that I let you know on the board, which is that the power is additive. So maybe that's your first step here. I strongly encourage you to take that as your first step. So let's look at that. So what is our total power? Well, P total is equal to P1 plus P2. In other words, 40 watts plus 60 watts. So our total power in this circuit is 100 watts. Let's write that number in because that's really going to help us solve the whole rest of this. Where do you want to go with this next? Well, you always want to look at where you have the most information. I would say you have the most information down here, specifically information you can use to find your total current. Because once you find your total current, you actually know your current across 1, your current across 2, which will be enough information to allow you to find the voltage drop across each one, and then to work your way backwards and find the resistance across each one. Okay, so first things first, we're going to find I total. So I'm going to go over here next and say that P total equals I total V total. Right, P equals IV. Power is the product of current times voltage. So I have 100 watts, and that is equal to I total times my voltage, 120 volts. So I think I know what that is, so I'm just going to make sure so I don't embarrass myself. Yeah, 0.83. Okay, so I total is going to be 0.83 amperes. So unfortunately, I didn't choose a number that would make it easy on myself. But let's substitute that into our chart. everywhere because in a series circuit, our current is the same everywhere. So 0.83 amperes, 0.83 amperes. Beautiful. Now, I really just need to make a note of that I know I total is equal to I1 is equal to I2, which will be equal to what we just calculated. I'm just making sure I'm going to max out on my points by showing this work. Now, I would suggest from here, going in and figuring out voltage drop across resistor 1, voltage drop across resistor 2. So to me, what's next is you can solve for V1, you can solve for V2. So let's do that. Well, we know V1 can be found by using P equals IV once again, but this time we'll say P1 equals I1 V1. In other words, 40 watts, or the power of light bulb 1, is equal to 0.83 amperes times an unknown voltage drop across that bulb. So solve that. So I got 48 volts. I'm just rounding. Okay. So V1 is going to be 48 volts. I'm going to write it in. V2 we're going to find the same way, but we'll do P2 equals I2 V2. In other words, 60 watts equals 0.83 amperes times an unknown voltage. So now I'm going to do that. 60 divided by 0.83. So here I get 72 volts, approximately. Now what you'll notice here, so let's write that. 72 volts. What you'll notice here is V1 plus V2 is approximately 120 volts. It's not exact because I rounded the current. I've been rounding as I'm going, so that's not ideal, but it approximately adds up. So that looks good. The voltages check out beautifully, and now we can work our way back, and we can address this part of our chart, solving for resistance 1 using Ohm's law, V equals IR, solving for resistance 2, V equals IR, and solving for REQ using V equals IR. So let's do that. So V1 equals I1 R1. So we have 48 volts. I mean, for me, it makes more sense to set this up like this, but I just noticed that when I see people's tests, they typically stick to this format. But for now, I'm going to just switch over to this. So we have 48 over 0.83. 48 volts over 0.83 amperes. So let's see. Right, so resistor 1 is about 58 ohms. And again, I'm rounding. I apologize. 58 ohms. Resistor 2, we're going to do the exact same thing. So I'm going to say R2 equals V2 over I2. So I'm going to have 48 volts over 0. Oh, I'm sorry, it's not 48. What was it? 72. My bad. 72 volts over 0.83 amps. So see what you get here. I got 87 ohms. And you could do this one of two ways. If you want to find REQ, we know we can just find the sum of resistor 1 and resistor 2, or you could work your way backwards from V equals IR. So I'll show it to you both ways. How's that? So we either can do REQ equals R1 plus R2. In other words, 87 and 58, which is approximately 145. Or I can work my way backwards and say REQ is equal to V total over I total. In other words, 120 volts over 0.83 amperes. So 120 divided by 0.83, 145 ohms. So either way you get the same answer. Whatever is your preference. I think adding them might be easier. So yeah, that's it. So I just wanted to make sure that you saw a series circuit where rather than giving you the resistance, I gave you the power. Hopefully none of this is too complicated. There's really only two equations we're using here. We're using V equals IR, and we're using P equals IV. And everything we're doing is built around these two equations. So these are really all we're implementing right now. So don't feel overwhelmed by this. It looks like a lot, but not anything too complex. Okay. I do want to talk about parallel circuits.